All right, so first one here. What are they asking us to do? What are they asking us to do? Okay, they want us to, based on the graph of this function, they want us to evaluate the function at f of 0. So what are we doing there? What does this mean? F of 0. X is 0. So we're plugging in an x value of 0 into the function. We don't know what the equation is, but that's all right. We just know that we're going to figure out when x is 0, what's the output of the function based on the graph. So x equals 0 would be right here, in this case, right on the y-axis, wouldn't it? So we're just going to go down, we're going to take the vertical line, x equals 0, and intersect it with the function to get 0,
Negative 5.
-5. So what's the answer?
Negative 5.
-5. Okay, everybody see that?
Yes.
Okay, no big deal. So problem like that, then let's just go ahead and enter these and verify that we're doing it right here. -5. Oops, forgot to. I didn't hit check, did I? There we go. Okay. Yeah, how about that? What about this one? Enter the answer, it fills in the blank. So the function f of x is graphed below. This time we're trying to solve the equation f of x equals 0. So what does that mean? We're solving the equation. We're putting in x values. What are we doing?
Y equals 0.
Y equals 0. Yeah. F of x is just a fancy name for y, so we want to know when is y equal to 0. Well, y equals 0 is just that line right there. That line right there. Is there an intersection with the graph?
1.
Right there at the point 1, 0. So what's our answer?
1, 0.
1. Well, just 1.
Oh, yeah.
We just want the x value, right? So when y is 0, x is 1. There's only one answer, one solution for that one.
This is the non-graphing?
This is the graphing one. Yeah. Okay, what about this guy? Same thing. This time we want to know when does f of x equal -2. I wish there was one, I kind of wish we'd had one where there were two solutions. What if, hypothetically, what if this had said f of x equals -6? What would I do? Go down 6. I want to know when does y equal -6. So I would just draw a horizontal line through y equals -6. Every point on that line has a y value of -6, doesn't it? So what are the ones that intersect with our function? Well, that's going to be when x is -5 or x equals -1.
So would you put the or sign?
No, on this one, these are ones where it's just going to say separate your answers with commas. Yeah. And it'll always be that way when there's multiple solutions to an equation. So that would be our answer for that one, right? Okay, everybody good? Okay. Whoops. Okay. So then what about this? Same kind of thing. Well, actually, not quite the same kind of thing. Yeah. We can use Desmos though, right? So here's one where we're given a function. I want to evaluate that function when x equals 8. So technically all I'm doing is plugging 8 in for all the x's, right? But we can let the technology do that for us because this is a graphing technology test. So we'll just open up Desmos. And we're just going to define the function. We have to use function notation because we're going to use this as a function, right? So we just say f of x equals 9/5 x squared minus 126 x plus 466. Okay, so there's our function. we want to know, we don't need the graph on this one though, do we? We could use the graph. We could graph the line x equals 8 and find the intersections, but it's easier just to use Desmos, that function that I defined in line 1, and ask Desmos to evaluate what I defined as f at 8. We're supposed to round to the nearest tenth, so it's already rounded. What's the answer?
6.8.
6.8. Okay. Same kind of thing, only this time we're trying to solve the equation using Desmos, solving the equation 2 times the square root of x minus 2 plus 5 equals 4. So what do I do here?
You just put that in Desmos.
Good. So I'm going to graph the expression on the left side, separately graph the expression on the right side, and these expressions are equal when their graphs intersect, right? So we'll come in, I don't have to use f of x's here, I can just use y's. I'm not going to evaluate the function. So I could go up and just change this whole thing to y equals 2 times the square root of x minus 2. I got to get out of the radical. What do I do?
Space.
No, arrow, right arrow to get out of the radical. So now the plus 5 is outside of the radical like it needs to be. So there's the graph you can see on the right for that expression. Then we'll go down and set y equal to the right side of the equation, which is 4. And we'll do this all year, right? What do we see?
No answers.
No intersection.
NA.
So NA or NS.
Why do we hit space?
Hmm?
Why don't you hit space? You hit the arrow?
You hit the right arrow to scoot out of the function.
Is
Yeah.
space bad?
Maybe it works. I don't
It
know.
doesn't work.
It doesn't
Is
work?
that why we got that one
Okay.
wrong?
Okay, next. Okay, same thing, right? Same thing, only this time, I'll just change that top one. We have something quadratic, so maybe we'll get more than one solution. So there's the left side, right? And on the other side, we're going to graph y equals negative 12. And now we just got to go find those solutions. So there's one there, and there's one there. So rounded to the near, okay, now it's possible, I got to fix something in Moodle. 'Cause
Whenever I click on it,
what's that?
whenever I click on like those points,
Mhm.
they never show up.
Yeah, sometimes that's just zoom in a lot.
Yeah, you
I
got,
always
right.
do that. I zoom in way too much.
Nah.
Really? On your phone or
No.
on the computer?
On the Chromebook.
You'll have to show me that,
All right.
because I've never seen that before. So what are my answers then, rounded to the nearest tenth? 5.5 and 10.6. Okay, I got to see if, I'm curious to see if Moodle, I might need to change something on this, because I think that the Wireless plugin does this wrong. I think it rounds down instead of up. We'll see. You tell me, has it been doing that? Has anybody ever seen this before? So if I put in 5.5 and, what was it again, negative, no, 10.6. That should be, oops, that should be right.
Oh, oh.
Yeah, see, look what it says, 10.5 and 5.5.
So what do we do then?
Nothing. You just flag it and I'll give you credit for it if that happens.
Yeah.
So it said 10.5. Now I'm wondering, I just want to see something here. Sometimes I wonder if Desmos rounds. I kind of want to get to the bottom of this. Let me graph this on the graphing calculator and see. Yeah, if that happens, for sure, just flag it. I'm going to go back and adjust those problems, but I want to see one thing. I want to see if it's just Desmos not rounding to enough places, or if it really is something I can fix. So if I go into the graph here, what were these functions? Oh man, don't do that.
Yeah, it was so gross. That was easy.
Oops.
Everyone's walking out. Shaggy, you know? Supposed to be there like 12.
Okay, so here on the graphing calculators, this is worth looking at too. So how would I find these intersections on the graphing calculator? Because all we've done are just intersecting lines. So we'd go second, calc, 5, and then that's the first curve, so I'd hit enter and enter. But now for a guess. See, look what happens here. If I trace along, I can specify which one of these I want to find by getting close to one or the other. So if I get as close as I can to that actual intersection, okay, see what's going on here. So this one, so Desmos doesn't take these out to very many places because this one is 5.450 stuff, right? So that one really does round up to 5, or 5.5, right? Let's go over and find this other one. This is a little bit of an issue with Desmos, maybe. See, look what that is. That's actually supposed to be 10.5 because it's 10.54951. Desmos rounded it to 2 places. Do you see the problem there?
Mm-hmm.
So, how do we deal with that? Call the people who run Desmos. Maybe if Desmos is always going to round to 2 places, maybe I should just change those so it says round to 2 places. Okay. Gosh, more work. Yeah. Okay, I'll do that. I'll do that though. You see how that would fix it though? Yeah. Okay.
They automatically do that for you, so you.
Yeah. Yeah. Because if they round only, if they're rounding to 2 and we're rounding to 1, they may not agree. Yeah. Okay. Great. All right. Well, I can fix that though. Okay. How about this guy? Back on track here. So we have a limit question. As x approaches infinity, f of x approaches blank. You're filling in the blank. So how do we think about this? What does it mean as x approaches infinity? Where's the ant going?
Up or to the right.
Good, to the right. X is horizontal. We're going in the horizontal direction, infinitely far in the positive direction. So that's infinitely far to the right. So we got to ask the question then, as the ant goes to the right forever, horizontally, what is he doing vertically? Going up forever. So y is approaching infinity. Okay? All right, so
Species, is that what you're gonna say?
Different species, things like that.
okay, what about this one? As x approaches negative infinity, f of x approaches what?
Negative infinity.
Yeah, because as I go to the left, the function goes down also, right? Goes down. So I should end up with negative infinity, okay?
That's your answer, just a.
That's our, just negative infinity. That's it, 'cause it's going down forever. Now, what would happen though, there's one other possible kind of question that you could see. Okay. What if, let me do this on a different page. What number is this, 9? Okay, what about one like that? What's the answer going to be there? As x approaches negative infinity, f of x approaches what?
-3.
Yeah, everybody see that? As the ant goes forever to the left, the y value sticks to -3, right? Okay, does that make sense? All right, so back over to here then. Average rate of change. Okay, what's that mean? Average rate of change over the interval x equals -1 to x equals +3. What are they looking for?
When you go over -1 and up.
To there.
Yeah.
Okay, good. So we're going from the point at -1, 6 to the point at 3, 2. Okay, so we want to know
Slope, right?
slope. That's it. The average rate of change is just going to be the slope between those points. So between those points, I would always want to start at the left point, right? When you calculate slope, you go left to right. So from that point to that point, if I draw a slope triangle, let's always do the rise first. What's my rise going to be?
4.
Negative.
-4.
-4. God damn.
And my run is
-3. Oh,
Try.
positive.
positive 1, 2, 3, 4.
I don't have my glasses on.
So my slope then is -4/4, which simplifies to -1. Okay. So now this makes sense though, right? I want you guys to start taking a little more time and assessing whether your answer is reasonable. Does that make sense that if I'm going from there, a line that's going to go through there, first of all, -1 seems about right. We're rising and running by the same amount. Does negative make sense? How come? It
It's
does.
going down.
It's going down, yeah. A decreasing line has a negative slope. An increasing line has a positive slope. So those are the kinds of things you can look at and catch some mistakes sometimes. If things just, you could know if we got a positive answer, that's obviously wrong, right? Okay. Okay, what about this one? This function has a local what? Minimum, where?
-3, 1.
Okay, -3, 1, how do I have to enter a point?
X and Y.
And I have to put them in parentheses, good. So -3, +1, boom. Okay, this one has a local minimum where?
0, -6.
Yeah, everybody see that? 0, -6 puts us right there. Okay, select all the graphs that represent a function. So yes or no?
No.
No. How come?
The vertical line.
Vertical line test. Good.
Yes.
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 Yes. Yes. No.
Got it. Okay, that's it. Easy, right? Piece of cake. Turn your desk around. Have at it.
Ellie. Ellie.
See?
Ask him, we're going to lunch with chemistry.
Yeah,
Yeah, he did my chemistry yesterday.
go ask, I'll turn the heat a little bit for you, how's that?
Oh, that's good.